Hello, dears, and welcome to Al-Hussaini Virtual Lab Pathology Talks, Dips, and Practical Tips. Today, I'm going to also address another recently described utilization of the new immunohistochemical antibody, the H3K27me3, this time in oligodendroglioma. So let's see how it works. This is a case of a 30-year-old female patient who presented with right frontal brain tumor. And as you can see, these are the neurons, and there is infiltration of the cortex, of course, because of the presence of the neurons, by a tumor with tendency at satelitosis. The tumor cells are surrounded by the malignant cells. Those show some clearing around the cytoplasm. Other areas showed more or less monotonous proliferation. This is important, monotonous proliferation, similar cells rounded in nuclei with a clear halo, and then there is a proliferation of the thin layered vessels forming what is known as the chicken wire-like appearance. Scattered mitotic figures are also seen. In other areas, calcifications are detected, samoma, body-like calcification. So we're talking about the morphological features more or less similar to oligodendroglioma, and other more cellular areas, perhaps a mitotic figure here. Really, all in all, the appearances would be very much suggestive of oligodendroglioma, probably the anaplastic or a grade 3 oligodendroglioma. But we have to prove it by immunohistochemistry or other molecular testing as per the recommendation by the WHO 2021 classification. So we start with the GFAP antibody. And remember that GFAP is positive in oligodendroglioma. Previously, we thought that GFAP might be negative in oligodendroglial tumor versus astrocytic tumor, but this is no longer holding true because we know that GFAP can also be positive in oligodendroglioma. But remember that with GFAP, as I previously alluded in a previous video, that GFAP can beautifully highlight the microvascular proliferation, and this is one of the most important utilities for GFAP from my point of view. Now, next step would be to do the IDH staining, and the tumor was positive for IDH1 immunohistochemistry. So this is a diffuse glioma that is GFAP positive as well as IDH1 mutant. Now, the next step is to do ATRX, and ATRX is known to be mutant with loss of a nuclear stain in astrocytic tumors. So once this is retained, the possibility that we're dealing with an oligodendroglioma should be entertained. But at this step, most people would resolve to do 1p19q, which is not present or not readily available in many labs in countries with limited resources. Because of that, we're trying to sort out this important differential diagnosis by immunohistochemistry. And recently, H3K27 trimethylated has been described as a surrogate marker in IDH-mutant gliomas for oligodendroglioma. There is loss of the nuclear stain in the tumor cells in the presence of positive internal control. And this is a higher power magnification. The endothelium is positive here and here, while the tumor cells are negative. Now, in conclusion, that would be supportive of the diagnosis of an oligodendroglioma, IDH1 mutant, because of the morphological features of anaplasia. The CNSWHO would be assigned a grade 3. Now, these are a couple of papers that really first described and then affirmed the utilization or the usefulness of the H3K27 trimethylation in the diagnosis, supporting the diagnosis of oligodendroglioma. Not only this, but in this paper, actually, they could show that the presence of the H3K27 trimethylation, lack of staining, is prognostic. This is associated with more aggressive behavior, similar to the case that I shared with you. I hope you find this tip useful in your daily practice. Thank you.